So in last session we discussed about all these queries, what is a master table, what is a tail table, and how to insert, and how the joins, what are the different types of joins available, and how to make use of those joins. So in today's session we are going to discuss about constraints. Constraints are nothing but condition checking before the data is getting inserted or updated or deleted, whatever. I mean, if you're making some changes to the data, before applying the change, it will check for these constraints. So in last session, at the end of the session, we discussed about what are the different types of constraints available and what it will do, what is the job of each constraint. So if you see, the first one is primary key constraint, unique, not null, check, and default. These are the 5 different constraints that are available. Now let's start with each and every constraint type. So first, I'm creating a table and I'm going to explain you where we can define these constraints, how to define these constraints while defining the table. Okay, first of all, for the first point you have to remember is constraints can be applied only on columns. So for each level, for each column, you can set some constraint. Let's see one by one. First, let's start with primary key. I'm creating a table, primary key. So in this, using this table, I'm going to primary constraint. So I'm defining them as primary key column. Primary key column will make sure that no null values. In other words, it will provide uniqueness or any company, and whenever a new employee to each and every employee. So each and every employee will get an employee ID. Why? Because to refer them uniquely, there should be some uniqueness. There may be a same couple of guys with same name, like another name also XYZ. So in that case, it is very difficult to find these two guys records. So to uniquely identify this primary key column, this primary key constraint will be defined on any one column of the table. So if you define employee ID as primary key column, primary key constraint, then you cannot insert duplicate records. That means a unique ID will be created. In your real time, for example, whenever you are generating or creating an email address for you, for let's say gmail.com. If you try to give, if I give rupesh71@gmail.com while creating a new ID, it will check the existing ID, and if the same ID exists, then it's not gonna give the same ID, and it will prompt with new IDs. Okay, these are all the available IDs. The ID you are looking for is already exists. So why it is giving unique ID? Every user should have a unique mail. So that's why it is prompting the available IDs if the ID you have given is already exists. In the same way, here, this particular column, if I define it as primary key, then it will make you pass any duplicate record and throw an error saying that the record, the ID is already present in the database. Whenever you are defining a master table, whenever you are defining a master information, whenever you are storing master information, this primary key is very, very, very important. It plays a major role while storing the data of master records. And if I define a primary key on any one column, that column is referred as primary key column. For example, in this table, employee ID is the primary key column. Now let's see how this primary key works. So I'm defining only 2 columns. My intention is not to test how many columns and how to insert data. My intention here is to test the primary key constraint, how it works. So I'm gonna define only 2 columns. One is primary key column, that is integer data type, and another one is name column, that is varchar data type. Now I am executing this table. The table created successfully. Now let's see the magic. So now I am inserting the data into this table. Insert into primary key testing values. I'm passing employee ID as 1 and the name as Rupesh. So if I execute this, so it executed successfully, and you can see the same data inserted into the table by executing the select statement. You can see the data entered. Now, by mistake or intentionally, if I try to execute the same query again, so the values that it is passing to the database table, primary key underscore testing, are again 1 and Rupesh. 1 is already present in the database, so whenever I try to pass the same ID, it means a duplicate ID or duplicate value to the column which is defined as primary key, then it will throw this error message. Violation of primary key constraint, and this is the name of the primary key, cannot insert duplicate key in object primary key underscore testing. Why? Because I've defined this one as primary key. And now I'm giving the ID 2 and name as Rupesh. I'm not changing the name. Name still remains the same. This is inserted successfully. Why? Because I have not defined primary key constraint on the column employee name. I define primary key only on employee ID column. Only one primary key column is possible per table. So if you want to define any one table and if you want to set some primary key, then in that case you can set primary key for any one column in the table, either employee ID or employee name, whatever. It's your wish. But the thing here is you can set primary key column. You can create only one primary key column per table. Now if I give 3, it will take. Why? Because the ID 3 is not exist in the table. Now what I'm gonna do here is I'm gonna pass null value. I don't know what is the ID and I don't want to pass either 1, 2 or 3 which is already exist. So if I try to pass null, it is throwing an error saying that cannot insert the value null into column employee ID. Why? Because it is defined as a primary key column. So as I told here, we'll make sure no null values. This is the example. When I try to pass null values, it is throwing an error, and also no duplicates. I've seen so many examples by passing duplicate records. So the points to remember here is primary key column can be only one column in the table, and the column for which we define primary key is called as primary key column, and primary key column does not allow null values, and primary key column does not allow duplicate values. So this is about primary key constraint. Now this is fine. Let me make it as primary key. This is done. Now what is the second constraint that is available here? The second constraint is unique. What is the difference between primary key constraint and unique key constraint? The most important interview question. Wherever you go, you'll get these interview questions if you are giving interview on SQL Server. Let's see this. Unique key constraint. And how this unique key differs from primary key. If you see the description what I have given here, will make sure only one null will be accepted and no duplicates. As far as duplicates is concerned, it is same as primary key, but null values are concerned, it allows only one null value. What unique key says is, unique key says that for me, null is also a value. I will not duplicate even null. That means I will allow only one null. Null is like just 1, 2, 3 for me. I will allow one null, I will allow 1, 1, I will allow 1 time 2, I will allow 1 time 3. It says I will make everything unique in the world. Whatever the value you are passing, I will make it unique, including null. So let me create a table. Create table unique. I'm giving some dummy names. Don't go with these kind of names whenever you are working in real-time projects. Underscore testing to them. To demonstrate these things, I'm giving some names like this. So here, what I'm gonna do, I'll write all the queries whatever I've written. This is the second time this is the one I tried. Fails. And then what I've tried, I have tried with 2, and then I have tried with 3, and then with null. So this one also fails. Why I'm taking these queries is I'm going to use the same queries again here. That's why. So while testing the unique path, I'm going to use the same queries. I'll keep it here. Now I'm defining the columns. Employee ID as integer, I'm defining it as unique. You can give unique or unique key like this. And the next column here is employee name. I'm defining it as varchar of 50. So now you can see the table create structure is here, the definition is here. I'm executing it. The table created successfully. Now what I have to do here is I should not run this insert statement as is. Why? Because the table name is changed to unique key testing. So let me replace the table name. I have to write the same queries again, which will take some time. So better to make use of the queries that I have executed as part of demonstrating primary key. First query. Insert into unique underscore testing, values are 1 and Rupesh. So this is perfectly fine. What unique key will do is it will make everything unique, including null. This is the first time I am passing the value 1, so it accepted. This is the second time I am passing 1 value. So already there is an ID 1. This unique fails and hence it throws the error saying the violation of unique key constraint. Unique so cannot insert duplicate key into the objects. Now what I'm going to do is I'm going to execute with a new ID, that is 2, which is not present, so it has taken in. And again I'm using the ID 3. This is also fine. So after that I'm taking the null path and executing it. So it is taking the null value, not like primary key. When I declare primary key on the same column, when in the table primary key underscore testing, when I try to pass null value, it error saying that it won't allow null values. So this is one difference between primary key and unique key. Primary key will allow one null value, whereas unique key will allow one null value, whereas primary key does not allow any null values. Now what I'm trying to do is I'm gonna execute the same query passing null for second time. So it throws error saying that already one null is given. You are trying to pass another null into the same unique key column. So this is how the unique key works. So this is one difference. Now you found what is the difference between unique key and the primary key. The major difference is both are meant for providing uniqueness, whereas unique key allow one null value, whereas primary key does not allow null values. And other differences, one more difference is primary key is one column per table, whereas unique key you can have n number of columns per table. There is no restriction. So these two are the major differences between primary key and unique key. And there is other differences like primary key can be used in foreign key relationships and so on. We will discuss about it when we discuss about foreign key relationships. The next constraint is not null. What this not null will do? Let's see that. So not null constraint. Primary and unique key in the same table. Yes, you can use it without any problem. You can use, but the same condition will apply. Only one primary key and the remaining columns you can define as unique key. For example, if you have 10 columns and if you want to provide only unique data in all the columns, in that case define one column as primary key and the remaining columns as unique key. It all depends on your requirements. Now let's see not null constraint. What not null constraint will do? As per the discussion we had in last session, not null will make sure no null values. It is not gonna check anything else. It will make sure that no null values will be passed into the column. So what I'm gonna do here is I'm creating a table. Create table not null underscore testing employee ID as integer. I'm defining not null for this. Okay. Now employee name. I don't bother about this. I'll declare it as 50. So here what I'm gonna do here is I'm gonna make use of the same queries to insert the data. I mean to test the not null constraint. So this is fine. First let me execute this table. This table created successfully. Now I'm gonna change this table name. Why? Because I'm gonna demonstrate this not null in a new table that is with the name not null underscore testing. Okay, fine. This is done. First, I'm passing ID 1 and column is not null. Sorry, column value is not null, that is ID 1 into the table not null underscore testing. This is perfectly fine. Why? Because I'm not passing null value. That not null will check only the null values. If it is getting null value, then it will throw error. Here, this is the case where I'm inserting ID 1 again and the value Rupesh again. It executes successfully. Why? Because the value that I'm passing is not null. It won't check for any uniqueness. What it is going to check is only not null or not. Okay. Now I'm ID 2. So no issues. Here null value. Here comes the issue. Okay. It don't accept null values. So that is why this constraint is called as not null constraint. So whenever I pass, whether it is the first time or second time, it won't bother. If it gets null value, that's it. It will fail the query. It will not insert the data. And you can easily say this. What will happen if I try to execute the null again? The same result. The data will not be inserted. Why? Because we are passing null values into the table and into the column which we define as not null. Here not null plus unique will become primary key, right? This is one thing you have to remember. Whenever you want a primary key functionality in two columns, let's say you are maintaining the data of US citizen, or let's say Indian, you are maintaining the data. So the mobile number should be unique. The employee ID should be unique and also not null. And email ID should be unique and not null. Right? So three columns it should be unique and it should be not null values. So but the problem here is you can define only one primary key column. How can you achieve the primary key concept, primary key type of functionality for the remaining two columns? If you use unique, the problem is it will allow one null. So the combination of not null plus unique will make sure that it will act the column with not null and unique will act as a primary key. And how to define that? Create table not null unique underscore testing. So what I'm going to do here is employee ID integer. I'll define it as primary key. Next, employee name varchar of 50 not null unique. This is how you can define a table with a column. One is primary key and another one is not null plus unique, which is nothing but a primary key. Now let me insert the data and see. Insert into this table values 1 comma Rupesh. This executed Sorry, I missed the quotation mark here. So this one executed successfully. Why? Because these two records, this either ID and Rupesh value is not available. If I execute this, it is going to throw error. Why? Because already these two values are present. Now I'm going to change the ID and the name remains the same. It is saying the unique key constraint fails. So why? Because I've defined it as unique, not null. Now what I'm going to do here is I'm going to define it as null. This is also going to fail because of null constraint. So the only way is you have to pass a different name here. Different name and different ID. Sorry, this should be 2. If I execute this, now it is accepted. So this is how you can provide the primary key functionality to any column by using not null and unique constraint. Select that from not null unique testing. If you execute this, you can see the data will be always unique. Okay, always like primary key data, primary key column data. So this is about not null constraint. Now let's see what is the next one. The next one is check constraint. What check constraint will do? Check constraint is a useful one whenever you want to have some restriction before inserting the data. For example, by mistake in the salary column, if I enter as 1000, that one will take it. Okay, so I can have some check. The salary should be always greater than 10,000. In my company, the salary will be minimum of 10,000. In that case, I can have the condition check. Let me demonstrate the same. Check constraint. Now, I'm creating a table. Create table. Check underscore testing. I'm gonna drop all these tables. No need to worry. The names are pretty awkward. This is not the best naming conventions. I'm giving naming conventions like this to make you comfortable, and it will be easy for me to remember what constraint I'm explaining here. So employee ID int check emp underscore ID greater than 100. Okay. So what I'm doing here is I'm having a check constraint. What I'm checking, employee ID should be greater than 100. If it is less than 100, don't take it. So let's see the same. Employee underscore name varchar of 100, or let's say 50, the routine one which we are taking, and the third one salary money check salary greater than 10,000. So as per the table definition here, the employee ID should be always greater than 100, and also the salary should be greater than 10,000 to any employee. Now I am setting the values 1, Rupesh, let's say my salary is 1000. If I execute this, it will say the check constraint fails. Why? Because the employee ID check, first what I have said is for 100 plus. If it is greater than 100, then only it is gonna be successful. Let's see by changing it to 101. So this one, the salary I have given is with the check constraint, and the value I have given is salary greater than 10,000. So what I'm going to do here is I'll give the name ID 101 and salary as 10,000. Even this one is a fail because the condition is not salary is equal to greater than or equal to 10,000. It is salary greater than 10,000. That means it should be 10,001 and above. So here I am giving 10,001. Now you can see the record inserted. So what this check constraint will do is whenever you are inserting, if you know the salary should be between 10,000 and 50,000, you can have some check like while defining it, salary greater than 10,000 and salary less than 50,000. So you can have some condition check like this so that the redundant data or junk data will not be loaded into your tables. Now let me execute and see the select statement here. So try to pull the data, what is inserted into the table check constraint. So you can see employee ID is 101 and name is Rupesh and salary is 10,001. You cannot pass value that is less than 100 for the ID, less than or equal to 100 for the ID, and less than or equal to 10,000 for the salary column. So this is the use of check constraint. So if you see, the primary key constraint will make sure no duplicates. It won't check for any value. It will check for only not duplicate values, and it will check for any nulls are getting passed into the column. Whereas unique key, it will check for only unique values, and it allows one null value. And the third one we discussed was not null, which will make sure that no null values will be passed into any one column. For example, PAN card number. A person who is paying tax should have PAN card number. In that case, you can use not null and also unique key constraint, or simply primary key. If you are using primary key for any other column in the table, then you can go for not null plus unique to make sure that every employee is having his own PAN card and it is not a null value. And last one, that is check constraint. Check constraint will make sure that the data is given in the check. So this is about check constraint. So the next one, default constraint. The name itself is saying what it is going to do. Default constraint will pass some default value if you don't provide the value in your insert statements. Whenever you are inserting the data, and if you don't provide any record, then it will take the default values. Let me take an example. Create table default underscore testing. I'm going to test this with employee ID as integer and employee name varchar of let's say 50, and the third one employee underscore gender character of 1. What I'm doing here is I'm setting default as M. So that means if I don't pass any value to this employee gender column, gender, then it will take M. If I pass F, then fine, it will take F. And what I'm gonna do here is the date of join. Date time is the column data type, and I'm taking a default. Get date is a function which will get the current date and load the date into the server. We are going to discuss about these functions in next coming sessions. So I am creating a table here. So command successful. Now let me insert the data into the same. Insert into default testing values. I'm passing employee ID and name. After that, I'm not passing anything. I'm passing null for the gender and null for the date of join. So if I execute this query, the query is successful. Okay, there is no not null and other constraints, right? So if you see here, the data what it is the same whatever we pass. So intentionally I'm trying to pass null values here. Then when this default works, if I'm passing null values and if it is taking null value, then in which case these default values is gonna work. So these default values is gonna work whenever you are not passing any value at all. Okay, let me show you an example for that. So I'm not passing any values for these two here. I remove the values. So to make the insert statement work, what I have to do? I have to pass the columns. What are those two columns? If I don't pass those two columns, then it will say the number of columns present in the table is different and the number of columns you are passing is different. Now if you see, I inserted this, I passed only 1 and Rupesh. Here the default value M is taken and the current server data is taken into the date of join. So this is how you can pass the values. You can set some default values. So this is the best example to demonstrate default. In the same way, you can set default values for any columns as per the requirements. And one more beautiful example for check constraint. Here, default is M, check employee gender is equal to either M or employee is equal to F. So what the second one here is going to do is the second one will check whether the employee gender is male or female. This one is going to help us in what case? This is going to help us in restricting the wrong values. Employee gender will be either male or female, okay, or any third one. Hardly 3 values will be there, and people, it will not allow people to enter either Y, B, C, D, some values like that, which are not relevant to this particular column. So what I'm going to do here is I'm going to copy the same queries here, check and default, and I'm going to name it as default check testing. So this query is executed successfully. Here, first what I'm doing here is I'm trying to pass null values. So, oops, this is not the table. I have to change the table names. So this is the table name. You can see the null values are passed, and this is also loading properly. Here I have here nothing is not here. Some value passed the list M or F, then it will throw the error in the check constraint will fail. So this is how the check constraint works. So I'm repeating here. You might be shocked by seeing this query executing successfully even after the check constraint is defined here. So the check constraint will check only when the value is coming in the query. This is executing fine. Why? Because I'm not passing any query. But the same if I pass, I'm not passing any value in the query. If I pass the value to the query in the query, let's say I'm passing Y, which is not in this list, M and F. So now it is going to throw error saying that the value that you are passing for the column which is defined with the check constraint is not meeting the requirement. So that is why it is not happening. It is not inserting. So this is how the check constraint works. The check, the default, the primary key, the unique key, and not null. These constraints will enforce some data integrity, and it will to enforce that the data that is inserting into the table is valid and non-junk data. If you don't have these kind of constraints defined in your table, for example, if the primary key constraint is not defined, the same employee ID will be given, can be inserted for different employees. That may lead to lot of conflicts, lot of problems. So these constraints are very, very, very useful while designing the database. Whatever the database design you take, the first thing people will go for is the constraints, where all the master tables are there and what constraints they are gonna define. So such an important one is these constraints. Now here, let me make this one fails. whereas this one this one will be succeeded, and this one also succeeded. Why? Because I'm not bringing value to the check constraint column. Fine. Now here we're going to discuss about couple of topics before signing off for the day. So how to add a column to the already created table? So if a table is created once, and if I want to add the column for the created table, what I have to do? So let's take this table as example. Default check testing. It has 1, 2, 3, 4 columns, and I want to add one more column. So the syntax for that one is alter table. I'm trying to alter the table and add what is the column name you want to give. Let's say PAN number, and I'm trying as teacher data type. That's it. This is just a column definition. And what you want to do, you want to add the column. So add column name and the data type. So to which table you want to add? Alter table name and add that column. So this one executed successfully. And now let me see what the table has. This has a column called PAN number, and it has no data. So this is how you can add a column to the existing table. Now let's see how to drop a column from a table. What I'm going to do here is I'm going to take the same table and drop the PAN number column. I don't want it. So the same query, alter table, the table name. Here you have to drop what you want to drop, and what is the column number you want to drop, that is PAN number. I don't need to specify data type or anything here. I am specifying drop column. I want to drop the column, and what is the column name, that is PAN number. And this is executed successfully. And if you see table, the column is missing. That means I dropped the column using drop alter table name, drop column name. So this is how you can add and you can drop the columns to a table, or you can add a column to a table, or you can drop a column from a table. And you can alter the data types. You can alter the data types of the table. Table called example of 1. This is what I have defined. Okay. Now what I'm gonna do here is I'm gonna change the data column or anything. Altering a column, what I'm gonna do here is sorry, alter table, and what is the table name in which I want to alter? Alter column, and what is the column name? Employee underscore gender, and I want to change it to varchar of 5. So if you see here, this employee gender column is of data type char of 1. Now if I execute this, the file name alter column type is column. So I cannot modify it. So first I have to remove the constraints and then modify the gender name. So let me take any other column to alter the data types. Let say employee name again as varchar of 50. Now what I am going to do here is I am going to make it as varchar of 10. So these are the constraints defined on the table. Now let's see whether the data type is changed for this column or not. To see the data types and the columns that are available in the table, the stored procedure is sp underscore help and give the table name. This one the stored column. Now we finished the employee name data type, column data type. Let's see what it is now. My goodness, it has taken 20 seconds to execute this particular sp underscore help text of a table. And you can see employee number data type is varchar and the length is 10. It was 50 earlier. Now it has become 10. What I'm going to do here is I'm going to change to 100. And this one is executed successfully. Let me execute this SQL text again. You can see the employee name data type is changed to 100. Varchar of 100. So this is how you can alter the columns, you can drop the columns, or you can add the columns to the existing tables. And the different things what we discussed, like this is how you can apply the constraints, different constraints on the tables like primary key, unique key, not null, default, and check constraints. In next session, what we're going to discuss is we're going to discuss about the foreign key relationships. That is very important in providing referential integrity. I'm going to explain you about what is referential integrity and so on. And after that, how to alter a table to provide constraints. Now, we provided constraints while creating the table. For example, primary key. I created a new table called primary key underscore testing, and I demonstrated primary key constraint. You can see the same here. I think it's somewhere here. Here. And we have a new table for unique key with the name unique key underscore testing to demonstrate unique key. And in tomorrow's session, we're going to discuss about how we can provide, or we can add, we can give constraints on already existing tables. So that will be very interesting. And these foreign key relationships is also very interesting topics. And we're going to discuss some example of functions in SQL Server. And also we're going to discuss about how to group the data. That means how to aggregate the data using group by